Today we are working on parallel and perpendicular lines. This will take 2 days again, or 2 videos. By the end of today, you should be able to determine whether lines are parallel, perpendicular, or neither. And hopefully you'll be, or actually not hopefully, you will be able to write equations of parallel lines and perpendicular lines. We got to have a positive attitude. So, a couple things. We need to go over what an opposite reciprocal is. A number of the form negative BA, where AB is non-zero rational number. So basically what that means is if I have 2/3, the opposite reciprocal of that is negative 3/2. Because reciprocal is where we flip the fraction, which makes it 3/2. And then the opposite part means, like, what's the opposite of 2? Negative 2. What's the opposite of negative 10? 10. We bring in the negative because that makes it opposite. So if you need a little bit more practice on this, what's the opposite reciprocal of negative 4/5? Well, we flip the fraction. And then we already have the negative here, so we have to take the negative away, so it's 5/4. So that is opposite reciprocal. Now, you know when they're opposite reciprocals if you multiply them and you get -1 as their answer. So, for instance, let's take the two right here that I just brought up. Negative 4/5 and 5/4 are opposite reciprocals. If I multiply those together, I get negative 20/20, and I get -1 as my answer. That means that these are opposite reciprocals. Now, parallel lines. This is an example right here of parallel lines, lines that will never touch or never intersect. And here's the key term: parallel lines have the same slope. Perpendicular lines, where it's a line that intersects with another line and makes a 90-degree angle or a right angle, the two lines are perpendicular if the product of their slopes is -1, meaning that their slopes have to be opposite reciprocals. So today we're going to focus on the parallel lines part and try to see if we can find lines that have the same slope. So, key concepts about slopes of parallel lines. You know if something is parallel if they have the same slope and different y-intercepts. Vertical lines are parallel if they have different x-intercepts. So notice these both have the same slope because the red line is y equals 1/2 x plus 1. This one is y equals 1/2 x minus 2. They have different y-intercepts, but they have the same slopes, which means that they are parallel. So, how do we find an equation of a parallel line? Well, what is an equation in slope-intercept form? Right away, you should know that's y equals mx plus b of a line that passes through. So we have a point, 2, 15, and is parallel to the graph y equals 4x minus 1. If it's going to be parallel to this graph, that means it's going to have the same slope. The slope of this line is 4. So I know that the line that needs to be parallel to it has to also have a slope of 4. So I know that my new line is going to have a slope of 4. I also know that this line has to have 2, 15 as one of its points. Now notice you have slope and you have a point. So that means we should probably use point slope to find our new equation. So what we're going to do is we're going to do y minus y1 equals m x minus x1. We're going to plug in our stuff that we know. So we know that our m is 4. We also know that we do opposites on point slope form. So we're going to do x, it says minus x1. Here's our x1, so it's going to be x minus 2. And then y minus 15. And some of you might circle that and say, yep, we're done. But that's not true because we need it in slope-intercept. Now, to get it from point slope to slope-intercept, all we have to do is solve for y. So get y by itself. So distribute the 4 over. So we have y minus 15 equals 4x minus 8. And then the last thing is to get rid of the negative 15 by adding 15 to both sides. and we get y equals 4x plus 7. Now notice, the original line that we wanted parallel with it was y equals 4x minus 1. How do we know that they're parallel? Because they have the same slopes and different y-intercepts. So this would be our answer right here. That is our line that is parallel to this line. Why don't you go ahead and try this one and see if you can get the same answer as me. So go ahead and pause the video and try it yourself. Alright, so let me walk you through how I did this one. So we need to write an equation that is parallel to y equals 2 over 3x minus 1, and it also goes through 12, 15. And our equation has to be in slope-intercept form. So what I did was I wrote the original equation, and I found the slope, which is 2 over 3. So that means my new line has to have a slope of 2 over 3. So I have a slope, and I have the point 12, 5. So I'm going to use point slope form, which is right here, to try to get into y-intercept. So y minus 5, because 5 is our y, equals 2 over 3, because 2 over 3 is our slope. Then in parentheses we have x minus our x1, which is 12, but I did keep change already, and I can do that here too. Now, like I said in the previous problem, our main goal is to get y by itself. So to get y by itself, we had to add 5 to both sides. And we got y equals 2 over 3x plus a negative 3. Or you don't have to do the keep change, and you can say y equals 2/3 x minus 3. Now the original equation was y equals 2/3 x minus 1. My question is are these two lines right here, are they parallel with each other? The answer is yes. They have the same slope, and they have different y-intercepts. Moving on to the next portion of section 5.6, the key concept of slopes of perpendicular lines. Remember, parallel have the same, perpendicular has the opposite reciprocal. So look at this red line here. It has a slope of 1/2. Well, what's the opposite reciprocal of 1/2? Well, that is 2 over 1. Notice no negatives, so that means I have to put a negative here. So the opposite reciprocal is negative 2 over 1, which they have right here. Now they don't have it over 1, but that still works too. If I multiply these together, 1 times negative 2 is negative 2, 2 times 1 is 2. My answer comes out to be negative 1. So I know that since their slopes come out to be negative 1, when I take the slope of line 1 and the slope of line 2 come out to be negative 1, that means I know the lines are going to be perpendicular. So in these problems right here, I'm going to move this one down a little bit. When they ask us to say if it's parallel, perpendicular, or neither, you remember same slope. So I'll say same m, which m is slope. I'm going to say opposite, reciprocal slopes. And then neither means that they neither have the same slope or opposite reciprocal. So notice, one of these is in slope-intercept form, and one of these is not. So you have to get them both into y-intercept form, or sorry, slope-intercept form. So this one is already done, so you're good. So I'm just going to write it over here. This one you have to get in y-intercept form. So we need to get y by itself. The only thing I have to do to get y by itself is to divide everything by 2. And I get y equals negative 3 over 2x plus 3. So there's our new equation. And here's the other equation that we had, because remember we are given 2. Now I have to say if they're parallel, perpendicular, or neither. Well, their slopes are not the same, so I know they're not parallel. So that it's either perpendicular or neither. Well, if I take the slope of line, this blue equation right here, which is 2/3, and times it by negative 3 over 2, I get negative 6 over 6, and that comes out to be negative 1. So if their slopes come out to be negative 1 when I multiply them, my answer is perpendicular. And that's not supposed to be an I guess that's supposed to be an E. My bad. Okay, so we're going to move on to the next one here. And I'm going to move this one up now. It's the same type of problems. Now notice, this one is in y-intercept form, this one's not. So we got to change this one. This one's in y-intercept form, or slope-intercept form. We got to change this one. So, what we're going to do is we're going to rewrite that problem that we have to change. We have to get y by itself. So we're going to subtract 4x over first. We can't combine these. We can do keep change if we want. Negative 3y equals negative 4x plus 9. I could keep change here to know that's a negative 4x and a positive 9. We're going to divide everything by negative 3. And my equation is going to come out as y equals, remember, negative divided by a negative is a positive, so we're just going to leave it as 4 over 3x minus 3 because 9 divided by 3 is negative 3. Now let's compare 4 over 3 and 3 over 4. They're not the same, so it's not parallel. They're not opposite reciprocals because they're both positive, so it's not perpendicular. So my only answer for this one is neither. Try to get the next one on your own. As you can see in this next problem, this one was already in slope-intercept form, so I don't have to do anything. I need to change this one. What I did is divide everything by 6 to get rid of the 6 that was attached to the y. There's a 1 right here with this negative, so I end up with negative 1x over 6, and then 6 divided by 6 is 1. So now I have two equations. Here's one, and here's the other. If you look at their slopes, this one's negative 1 over 6, and this one's negative 1 over 6. And they have different y-intercepts, so you know that they are parallel.